Okay. We're going to start here. You don't have to write anything down on this. We're just going to kind of stay together and do a quick little review to knock some of the cobwebs off. And we're just going to put our radians on here. So we know if we start here, we're at 0, or we go all the way around to 2 pi, right? In degrees, what is this angle? 30. In radians, what is it? Pi over 6. Okay. So that's our first quadrant pi 6 angle, right? We have them in the other quadrants as well. All of the pi 6 angles are closest to the x-axis. So this is my second quadrant pi 6 angle. What is it? 5 pi over 6. Because if I go all the way to here, this is pi, right? So it's like 6 pi over 6, and I just back up 1. So this is my other pi 6 angle. What's it? 7 pi 6, because I just go forward 1, right? You hear, you back up 1, you go forward 1. Then my fourth quadrant pi 6 angle is what? 11 pi 6, because this would be 12 pi 6, and I back up, so I get 11 pi 6. Okay, we good? All right. In degrees, what is this angle? 45. In radians, what is it? Pi 4. Okay. So then my second quadrant pi 4th angle is what? 3 pi 4, because I just back up 1. And my third quadrant is 5 pi 4, because I just go forward 1. My fourth quadrant pi 4th angle is what? 7 pi 4. Okay. In degrees, what is this? 60. In radians, it is pi over 3. My second quadrant pi 3rds angle is 2 pi over 3. And then this one is 4 pi over 3, because I go forward 1. And then my fourth quadrant is 5 pi over 3. Okay? So then I've already had these. This is what? Pi halves, and this is 3 pi halves. Okay. Is it all coming back to you now? Hopefully it never left, but yeah, take your earbuds out, please. Okay. Because tomorrow you got a quiz, so let's make sure that we're over anything on the unit circle is fair game at this point. Okay, so again, this is all a review. We've talked about all of this stuff before in different, we're just piecing it together kind of. So for an angle theta in standard form, remember standard form means that we start here at 0. Positive goes counterclockwise, negative goes clockwise, and the vertex is at the origin. That's what standard form is. The reference angle is the positive acute angle formed, hold on, fix that, by the terminal side in the x-axis. So we're going to sketch the angle and its reference angle. So looking at number 1, 2 pi 3rds, what quadrant am I in? Second. And then that means I'm about right here. This is 2 pi 3rds. What's my reference angle? Pi 3rds, because that's how we come up with our values. We just have to know what's going on in the first quadrant and how to relate it. 11 pi 6, fourth quadrant. So this is 11 pi 6. What is my reference angle? Pi 6. There is a lot of vertical lines. Negative 5 pi 4ths. What quadrant are we in? Ooh. We start here. Negative 4 pi 4ths. Go one more. I'm here in a second. I know. Yeah, we're a little unsure. So negative 5 pi 4ths. My reference angle is what? Pi 4ths. It's always positive, always acute. It doesn't matter which direction you go to get there. It doesn't matter what the original angle is. Okay. Then it doesn't have one and it's a quadrantal. Yeah. Yes, so like if we ended up at pi halves. So his question is, listen, what if it ends up on an axis? So like if it ended up at pi halves, then your answer would be that it's quadrantal and it's on the positive y-axis. Because it doesn't have a reference angle. All right, so then number 4, 5 pi 6. What quadrant are we in? Second. So I'm right here. This is 5 pi 6. What is the reference angle? Pi 6. 7 pi fourths. It's in the fourth quadrant because 8 pi fourths is all the way around. So 7 pi fourths. And your reference angle is what? Pi fourths. Also known as 2 pi over 8. All right. Negative 7 pi thirds. What quadrant are we in? Fourth. So we start here. This is negative 3 pi thirds, then negative 6 pi thirds, then I got to go one more. So I'm here. So I start here and go all the way around like this. That's negative 7 pi thirds. What is your reference angle? Pi thirds. It's always positive, always acute, always the shortest way back to the x-axis. We good? All right, so if just identifying what the reference angle is when you have radians is super easy because it's just whatever the denominator is, right? It's that easy. But you also have to know which quadrant you're in so that you can do some more stuff with it, right? Okay, so let's look at number 7. It says use the reference angles and the trigonometric function values to find each function here. Okay, so we're going to write some extra stuff down that I don't necessarily expect you to write down when you're doing it on your own, and we didn't when we did it originally. And we won't on the back, but just these are the thought processes you have to go through. So if you need to look back at this, you've got it. All right, so sine of 2 pi thirds. 2 pi thirds is in what quadrant? Second. Okay, so that's the first thing you have to ask yourself. What quadrant am I in? In the second quadrant. Then you have to ask yourself, is sine positive or negative in the second quadrant? And how do we know? It is the y value, but what's our little... There you go. All students take calculus. And it's not all kids take algebra, which I heard somebody say the other day. All right, all students take calculus. So in the second quadrant, sine is positive. So this is positive. What is your reference angle? Pi thirds. Okay, so those are all things you have to ask yourself before you can actually find the answer. So now we just need the sine of pi thirds. How do you remember that easily? Square root of 3 over 2. Remember the hand trick? Remember the hand trick? So square root of 3 over 2. And it's positive, so your answer is just square root of 3 over 2. Stop talking. Okay. I know. All right. Secant. Oh, first of all, 5 pi fourths. What quadrant are we in? Third. We're in the third quadrant. Secant is the reciprocal of what? Cosine. Okay? And cosine in the third quadrant is what? Positive or negative? Negative. It's negative. Okay? I know. What's our reference angle? Is Lisbeth distracting you, Fernando? Is that the problem? Oh. Reference is pi fourths. Okay, so what I really need to find first is the cosine of pi fourths. What is the cosine of pi fourths? Square root of 2 over 2. Not my answer, right? I need the negative reciprocal of that, which is negative what? Square root of 2. So do you see all those steps? Which again, you don't always have, we're writing down just on these 4, and you can jot things down if you need to, but it's okay to just kind of keep all that stuff in your head if you can. All right, 11 pi 6, what quadrant are we in? Fourth, okay? In the fourth quadrant, is tangent positive or negative? Negative. Cosine's positive in the fourth quadrant. And then the reference angle is what? Pi 6, okay? So what is the tangent of pi 6? Square root of 3 over 3, and this is supposed to be negative, and that's my answer. Yes? Okay. Michael, take it. Ah, I know how I missed that. All right. Negative 2 pi thirds. What quadrant are we in? Third. We're in the third quadrant. Okay. Cosecant is the reciprocal of what? Sine. In the third quadrant, is sine positive or negative? Negative. And then my reference angle is pi thirds. So I really need the sine of pi thirds. Okay, so what's the sine of pi thirds? Square root of 3 over 2. Okay. Well, that's just pi thirds. Yes, it's going to need to be negative. But I need the negative reciprocal of that, so it's negative what? 2 square root of 3 over 2. Okay, we good so far? Yes? All right. So here, this kind of goes back to Parker's question earlier. The quadrantal angles. I don't think that y'all have a trouble understanding what a quadrantal angle is or anything like that, but I think that what some of you are struggling with is when to give that as an answer and how to answer the questions with it. So I just want to make sure we understand that. If I ask you what is the reference angle, and there isn't one because it's a quadrantal angle, or ask you what quadrant you're in, and you're not because it's a quadrantal angle, then your answer is quadrantal and where it is. And when we first did this, I didn't make you write the word quadrantal, but in turn, some of y'all aren't writing that as part of the answer, and it is part of the answer, so I'm going to make you write it 4 times now. So if you're at 0, or at 2 pi, or any rotation that gets you there, if you end up there, however you do it, then your answer is quadrantal, and then you put positive x-axis. Okay, so you put the word quadrantal, and then positive x-axis. If you end up at pi halves, however you get there, positive, negative, however many times you go around, whatever, then your answer is quadrantal. There you go. Positive y-axis. I did? Okay. Well, it feels like I didn't because nobody was writing as an answer. So just making sure. All right. So if you end up there, then this is quadrantal. And what do we write? Negative x-axis. It's a quadrilateral? All right, so if you end up here, then it is quadrantal. And we're on the negative y-axis. So if you can't answer the question because it's one of those, then that is the answer. Okay, does that help? All right, we all good so far? Yes? All right, flip it over. Okay, right now we are focusing on the unit circle. We are going to do some other things where it doesn't work out exactly like from the unit circle, but a unit circle has a radius of 1 unit. Because r is 1, so here's the radius, and that value is 1. Then we have a point xy. This is my point. This is the x value. This is the y value. This is where that little triangle comes in, right? So in that triangle there, the sine theta is represented by what? Y. Because sine is opposite over hypotenuse, so it's y over 1 when it's just y. Because the radius is 1. If the radius wasn't 1, it wouldn't just be y. It would be y over r. Cosine is represented by what? X. Tangent is y over x, because it's sine over cosine, so it's y over x. Cosecant is the reciprocal of what? Sine, so this is 1 over y. Secant would be 1 over what? X. And then cotangent is x over y. And your ordered pairs can always be written as cosine theta, sine theta. Cosine is x, sine is y. All right, so our 16-point unit circle, which we already know and love, right? This is just a little, the unit circle is frequently used to map pi 6, pi 4ths, and pi 3rds. Now, you could use it for pi 12ths and some other fractional equivalents of those things, but that's really, these are the main ones we use, and whatever multiples there are, as well as 0 or 2 pi, pi halves, pi, and 3 pi halves, which are the quadrantals. Okay, so it maps those onto, what their different coordinates are. All right, so now we're going to run through some more of these. We're not going to write down all that stuff this time. You can if you want to, but we're just going to think through that process. And one of the things that we need to focus on here is all students take calculus, right? It also gives you a little grid to think about. 3 pi 4ths, what quadrant are we in? Second. Is sign positive or negative in the second quadrant? Positive. What's the sign of pi 4ths? There you go. Secant. What is secant the reciprocal of? Cosine. Yes. Okay, it's cosine, so it's what? Cosine of pi is what? -1. What's the reciprocal of -1? -1. All right. Negative 5 pi thirds. Is it? Yeah. Okay, we're in the first quadrant. So everything's positive in the first quadrant. Cotangent is the reciprocal of tangent. What's the tangent of pi thirds? Square root of 3. Well, the tangent of pi thirds is square root of 3. So the reciprocal of that is square root of 3 over 3. Right? Yeah, you are. All right, cosecant. Reciprocal of what? Sine. This is 2 pi thirds. What quadrant are we in? Second. Are we positive or negative? Positive. Sine is positive in the second quadrant. Okay? So it's positive, so that just means I have to come up with the value now. The sine of pi thirds is what? Square root of 3 over 2. So I need the reciprocal of that, which is 2 square root of 3 over 3. And if you need to, again, jot some things down so you don't lose track of your thoughts, that's fine. Tangent of 3 pi halves. Undefined. Oh, something. All right. Cosine of negative 5 pi 6. So negative 5 pi 6, we're in which quadrant? Third. Okay. So we're in the third quadrant, and is cosine positive or negative in the third? Negative. So I'm going to put my negative sign so I don't forget. And then the cosine of pi 6 is square root of 3 over 2. All right. Cosine of 3 pi fourths. Second quadrant, are we positive or negative? Negative. So it's negative square root of 2 over 2. Tangent of 2 pi thirds, is that going to be positive or negative? Negative. What's the tangent of pi thirds? Square root of 3. Okay. What is the tangent of pi halves? Undefined. Now, the reciprocal of undefined is undefined. However, the reason we get undefined is because we put 1 over 0, right? And then the reciprocal of 1 over 0 is 0 over 1, and that's why we get 0 there. All right, secant is the reciprocal of what? Cosine. This is going to be in which quadrant? The fourth. And the fourth quadrant is cosine positive or negative? Positive. That means that the secant of negative pi fourths is what? Square root of 2 over 2. 5 pi fourths is in which quadrant? Third. Are we positive or negative? Positive. Okay. Tangent is positive in the third quadrant. And then the tangent of pi fourths is what? 1. Cosecant is the reciprocal of sine. Here we are in which quadrant? Third. So are we positive or negative? First sign. We're negative. Okay. So negative. So the sine of pi 6 is what? 1/2. But I need the reciprocal of that, which is 2. Yeah, so it's negative 2. All right. What questions do you have? Anything? It's all coming back to you now? No. But I will remind you that in Google Classroom, I put a, well, there's a, I guess they're called categories, but it says practice. And there's 2 quizzes that I put in there that you can take an unlimited amount of time. I can't see your score. I can't see even whether you took it or not, but it's just there for you to practice if you want to. You also have the Quizlets to practice with. So I would suggest if you have, haven't been staying on top of it, that you actually practice this year. I haven't decided yet.